In the endless expanse of our solar system, Jupiter stands as the true king, a massive, chaotic mystery that's kept scientists guessing for centuries. Every time we think we've figured out this gas giant, it throws a curveball, defying logic with its wild storms and strange inner secrets. Imagine storms so violent they whip winds at 640 kilometers per hour, and deep below them, hidden metallic oceans that shimmer beneath crushing pressure. Jupiter's chaos is beautiful, terrifying, and still far from being fully understood. Years of research have revealed just how insanely complex this planet really is. And just recently, astronomers uncovered 12 brand new moons orbiting the giant, bringing the total to an astonishing 92, more than any other planet in the solar system. These moons, ranging from just 1 to 3 kilometers wide, drift on distant looping paths. 9 of them even orbit backward against Jupiter's rotation, a clue that they might once have been wandering asteroids captured by the planet's gravity. Many scientists believe Jupiter's massive presence acts like a cosmic shield, protecting Earth from deadly space debris hurtling through the void. For years, astronomers believed Jupiter was the reason life on Earth even had a chance to begin, acting as our cosmic bodyguard. But new discoveries suggest that this protector role might not be as clear-cut as once thought. Long-period comets, born in the distant, icy outskirts of the solar system, take thousands or even millions of years to circle the Sun. Normally, Jupiter's massive gravity hurls most of these frozen wanderers out of the solar system before they ever come close to Earth, making comet impacts extremely rare, maybe once every tens of millions of years. In that sense, Jupiter seems like our planet's silent guardian. But here's the twist. That same gravity can also work against us. The gas giant's immense pull prevents nearby material from clumping together into a planet, leaving behind the asteroid belt, a chaotic region packed with rocky debris between Mars and Jupiter. Yet Jupiter's gravitational reach doesn't stop there. Its tug can alter asteroid paths, sending some hurtling toward the inner solar system, and occasionally straight toward Earth. History has already given us a warning. In 1770, Lexell's comet came within a mere million miles of our planet, a dangerously close call in cosmic terms. Scientists think Lexell's comet originally came from the frozen outskirts of the solar system before a close encounter with Jupiter changed everything, slingshotting it straight toward Earth's path. After circling the Sun twice, it crossed Jupiter's orbit again 9 years later, and that second meeting sent it flying out of the solar system for good. This became a key piece of evidence for the famous Jupiter shield theory, the idea that the gas giant acts as Earth's protector, flinging dangerous comets away. Early computer models even predicted events like the Shoemaker-Levy 9 impact on Jupiter in 1994, a dramatic crash that proved the planet's powerful gravitational influence. But back then, computing technology was far more limited, forcing scientists to work with rough estimates and smaller data sets. Modern simulations tell a more complicated story. New data show that short-period comets and near-Earth asteroids are far more common than the distant long-period ones. Jupiter's gravity doesn't just shield Earth. It also stirs up chaos in the asteroid belt, creating powerful resonances that fling debris inward. When asteroids collide, they scatter rocky fragments that drift into these unstable zones, sending some toward the inner solar system. The belt's inner edge is especially unstable because of something called secular resonance, which pushes material closer to Earth. So in the end, Jupiter isn't just our cosmic protector. It's also one of the reasons danger sometimes comes our way. If Jupiter were only a fifth of its current mass, it would still disrupt comets, but it wouldn't be strong enough to throw them out of the solar system. That means far more would end up hitting Earth. The number of these cosmic collisions is critical for life to evolve and survive. Earth's geological record shows that one massive impact roughly every 100 million years gives life enough time to recover and flourish again. But if those impacts happened every few million years, the planet's biosphere might never stabilize. Life would be constantly reset before it could evolve. Interestingly, some scientists even think those early collisions helped deliver water to Earth in the first place. As for Jupiter itself, the story of water there is just as fascinating. In 1995, NASA's Galileo spacecraft made a groundbreaking discovery. It detected water vapor in Jupiter's atmosphere for the first time using its near-infrared spectrometer. This was a huge clue about what's hiding inside the planet's turbulent clouds. Recent data shows that water makes up about 0.25% of Jupiter's atmosphere above the equator. That might sound tiny, but considering the planet's enormous size, it represents a staggering amount of water. Jupiter, likely the first planet to form in our solar system, still holds much of the leftover gas and dust that never became part of the Sun, making it a massive, ancient reservoir of the solar system's original materials. Understanding how much water Jupiter holds is key to unlocking the story of how our solar system was born. In recent years, scientists using powerful telescopes have detected surprising amounts of water hidden inside Jupiter's legendary Great Red Spot. Meanwhile, NASA's Juno spacecraft, launched in 2012, continues to orbit the planet, capturing stunning close-up data with its advanced instruments. Juno's findings have revealed even stronger evidence of water deep within Jupiter's clouds. Because this gas giant is over twice as massive as all the other planets combined, even a small fraction of water represents a mind-blowing quantity, far more than the total amount on Earth. And that water doesn't just sit quietly, it fuels some of Jupiter's most breathtaking phenomena. The planet's atmosphere bursts with lightning, flashes up to 100 times brighter than those on Earth, and even creates bizarre hail made of water and ammonia. Scientists have long known that lightning forms when water droplets collide with electrically charged ice crystals inside Jupiter's stormy clouds. But Juno has spotted dimmer lightning much higher in the atmosphere in regions so cold, around -87 degrees Celsius, that liquid water shouldn't even exist. So how is that possible? The secret lies in ammonia, Jupiter's natural antifreeze. When water ice mixes with ammonia vapor, it melts into strange, slushy droplets. These droplets then collide with more ice particles from below, building up massive electrical charges and unleashing bolts of lightning that illuminate the planet's violent skies. Beneath Jupiter's icy ammonia clouds, strange things happen. Tiny ammonia water droplets merge and grow until they're too heavy to stay aloft, turning into massive, slushy hailstones. These mush balls, as scientists call them, fall deep into the planet's thick atmosphere, carrying water and ammonia far below the visible storms. But the deeper we go, the stranger Jupiter becomes. For decades, scientists believed that all giant planets had solid rocky cores, the dense foundations around which everything else formed. That idea, however, is now being challenged. Data from NASA's Juno spacecraft has forced scientists to rethink everything they thought they knew about Jupiter's interior. By analyzing Juno's orbit, researchers discovered something shocking. Jupiter's core isn't solid at all. Instead, it's a massive, diffuse region filled with swirling, mixed-up material, part rock, part metal, and mostly gas. Temperatures there reach a blistering 20,000 degrees Celsius, with pressures millions of times stronger than on Earth. To simulate these impossible conditions, scientists at the University of Rochester's Center for Matter at Atomic Pressures use ultra-powerful lasers to squeeze materials to extremes. Their findings reveal that only about 18% of Jupiter's inner core is rocky, far less than expected. The rest? A vast ocean of hydrogen and helium, making up roughly 90% and 10% of the planet's composition, with just trace amounts of other elements swirling in its outer layers. Jupiter's heart, it turns out, isn't solid. It's alive with chaos. Hydrogen, the lightest element in the universe, behaves normally in Jupiter's upper atmosphere, just a clear, invisible gas like the one found on Earth. But as you dive deeper into the planet, the pressure becomes so intense that hydrogen begins to change into something completely alien. Roughly 10% of the way toward Jupiter's core, the crushing force transforms ordinary hydrogen gas into a strange, shimmering liquid called metallic hydrogen. This exotic material behaves like no substance found naturally on Earth. It's dense, fluid, and conducts electricity and heat almost as efficiently as metal. Imagine a sea of liquid metal swirling beneath Jupiter's clouds. That vast layer acts like a gigantic electrical generator, fueling the planet's immense magnetic field. On Earth, hydrogen can be cooled or compressed into liquid or solid forms, but it never turns metallic. It stays a poor conductor of electricity. Jupiter's environment, however, is a completely different story. Inside the gas giant, temperatures soar and pressures reach millions of times those at sea level on Earth. Under these extreme conditions, hydrogen atoms are forced so tightly together that their electrons start to move freely, the key trait of metal. The result is liquid metallic hydrogen, one of the strangest and most powerful substances in the universe, flowing endlessly beneath Jupiter's colossal storms. Under Jupiter's crushing pressure, hydrogen atoms are stripped of their electrons, creating a bizarre mix of free-floating nuclei and electrons, a metallic soup that behaves like a liquid metal. Scientists believe Jupiter's core could be filled with vast oceans of this strange substance, and estimates suggest that the core itself might be between 12 and 45 times more massive than Earth. This immense 40,000-kilometer deep layer of liquid metallic hydrogen, combined with Jupiter's lightning-fast 10-hour rotation, acts like a planetary dynamo, generating a mind-blowing magnetic field that stretches over 725 million kilometers into space. It's the largest magnetic field in our entire solar system, and it hides some of the most puzzling mysteries scientists have ever encountered. When researchers mapped regions more than 320 kilometers below the clouds, they found something unexpected: a strange magnetic zone called the Great Blue Spot, not to be mistaken for the planet's iconic Great Red Spot. For decades, scientists knew Jupiter's magnetic field was complex, but this discovery revealed just how chaotic it truly is. Jupiter's magnetic strength is about 20,000 times more powerful than Earth's, yet it's unstable and unpredictable. Unlike our planet's simple north and south poles, Jupiter's magnetic field doesn't behave neatly. It originates from a wide swath of the northern hemisphere and dives back near the South Pole. Even stranger, scientists have found a mysterious stable region just below the equator, adding yet another layer of enigma to the gas giant's untamed magnetism. The Great Blue Spot is like Jupiter's hidden second South Pole, a bizarre magnetic storm swirling near the equator. Scientists think its violent activity might be tied to huge pockets of ammonia deep in the atmosphere, fueling chaotic changes in the planet's magnetic field. Every year, the strength of this field fluctuates by about 1%, growing stronger in some areas and weaker in others. By the end of NASA's extended Juno mission in 2025, researchers hope to finally understand what's really happening inside this mysterious zone. Some even suspect that the Great Blue Spot could be linked to Jupiter's iconic Great Red Spot, since both sit along the same latitude. If true, it could mean that the planet's massive storms and its magnetic chaos are more connected than anyone imagined. While Jupiter's surface looks calm from afar, it's anything but. Like Saturn, it's a gas giant known for blistering heat in its upper layers, yet its atmosphere hides strange temperature extremes. The Great Red Spot, that monstrous storm twice the size of Earth, has raged for centuries. But it's not alone. Another feature, the Great Cold Spot, has baffled scientists for years. Almost as large as its crimson counterpart, this icy vortex stretches about 12,000 by 24,000 kilometers and is roughly 200 degrees colder than the surrounding atmosphere. It's an eerie reminder that even on a world defined by fire and lightning, there are places of haunting, frozen calm. The Great Cold Spot isn't a permanent feature. It fades, reforms, and shifts unpredictably. Scientists have found that its strange rhythm is tied to Jupiter's dazzling auroras. Because both appear and behave in sync, it's believed the cold spot is about as old as the planet's polar lights, thousands of years. Like Earth's auroras, Jupiter's are born when charged particles slam into its upper atmosphere near the poles. But while Earth's lights flicker and fade, Jupiter's are fierce and constant, powered not only by the sun, but also by streams of charged particles from its volcanic moon, Io. These auroras don't just glow, they pump immense energy into the atmosphere, heating the upper layers and leaving the lower ones cooler. That temperature imbalance creates a swirling, icy vortex, the Great Cold Spot, spinning separately from the glowing auroras that birthed it. Earth has its own auroral effects, but Jupiter's incredible size and rapid rotation trap heat and energy in ways that make its polar regions far more extreme. And perhaps the strangest twist of all, Jupiter doesn't actually orbit around the Sun. The gas giant is so massive that the center of gravity between the two lies just above the Sun's surface. In other words, the Sun and Jupiter are locked in a cosmic dance, orbiting a shared point in space, a reminder that even the mightiest star in our solar system doesn't rule alone. Both Jupiter and the Sun actually orbit a shared center of gravity, a cosmic balance point between them. For smaller bodies like Earth and the Sun, that point lies so close to the Sun's center that the effect is almost invisible. The Sun barely moves, while Earth appears to trace a clean orbit around it. The same rule applies to the International Space Station circling Earth. Both technically orbit a mutual center of gravity, though our planet's far greater mass makes it seem completely still. This pattern repeats throughout the solar system, from tiny moons to giant planets. But Jupiter is the great exception. Because of its staggering size, Jupiter's gravitational pull shifts the balance dramatically. The system's true center of mass, called the barycenter, sits about 1.07 solar radii from the Sun's core, roughly 7% above the Sun's visible surface. That means the Sun itself wobbles slightly through space as it and Jupiter orbit this invisible point together. It's a humbling reminder that even our mighty star doesn't sit perfectly still. It dances to Jupiter's gravitational rhythm. And as missions like Juno continue to peel back the layers of this colossal world, one thing is clear: Jupiter still holds secrets we've only begun to uncover. If you enjoyed this deep dive into the mysteries of Jupiter, make sure to like, subscribe, and turn on notifications. Your support helps keep these cosmic explorations going. Thanks for watching, and keep looking up.